The living battery that will power our future. What if the battery that keeps your heart beating wasn't metal, but living jelly? It sounds insane, but this animal in the Amazon has already built the perfect version. No wires, no dangerous mines. This creature can generate a ridiculous 860 volts, enough to power a microwave. And it literally made all that power just by eating its lunch. In this video, we're cracking open nature's secret blueprint for the ultimate battery. Section 1. The spark everybody. Meet the electric eel. And there are actually 3 different kinds. These aren't just fish. They are living, breathing power plants, and each one is stacked with thousands of tiny pancake-thin cells. Just imagine a 6-foot-long flashlight stuffed with biological batteries. Each tiny cell creates a small charge, just waiting for the signal. Then the eel's brain flips a switch. Boom! All those thousands of mini batteries fire at the exact same time. They're wired up so all their tiny voltages become one massive wall socket level punch. Nature spent 100 million years testing this design. We only figured out how it actually works in the last decade. Section 2. The weapon. So how does this thing actually use this insane power? For hunting, it sends out a few low-voltage pings, kind of like a radar, to find prey in the water. But the second it finds a target, everything changes. The eel cranks the power up to 400 hertz, blasting out rapid-fire pulses that make its prey's muscles twitch, giving away its hiding spot. And then, bam! A final devastating 100-watt pop to paralyze it. But for defense, it gets even crazier. If an eel gets trapped, it won't run from a predator. Instead, it literally jumps out of the water, presses its chin right on the attacker, and zaps it in the open air. Because water makes electricity weaker, this direct attack delivers a way more concentrated, terrifying shock. This is one of the most brilliant things in all of nature, and we have slow-motion video to prove it. Section 3. The leap to humans. Isn't it crazy that we're still using these big, clunky, toxic cans for our batteries? People with medical implants like pacemakers need major surgery every 5 years just to get the battery replaced. Soft robots are held back by briefcase-sized power packs. And brain implants are literally tethered to giant ports in people's skulls. What we really need are batteries you can bend, twist, or even tie in a knot. We need batteries that can just safely dissolve inside our bodies. And that is exactly what the electric eel has, a soft, flexible, and safe power source. Nature solved this problem millions of years ago, and our best engineers are just now catching up. Section 4, the lab hack, so we challenged these brilliant scientists to copy the eel. Researchers in Switzerland printed thousands of layers of specialized gels. By stacking 2,000 of these tiny gel discs, they hit an incredible 110 volts. And you can literally tie the whole thing in a knot around your finger. Then researchers at MIT pushed it even further, doubling the power. Okay, it's still a tiny amount of power for now, but it's already enough to run a microscopic device. The ultimate goal is to match the eel's insane power. We're not there yet, but these breakthroughs are a gigantic step to making flexible, implantable batteries a reality. Mid-roll CTA, if you think this is as insane as I do, go ahead and smash that subscribe button. Because next month, we're going to show you a plant that literally breathes electricity. You do not want to miss what's coming next. The future is here and it's completely wild. Section 5. The medical moonshot, okay? Just imagine this. A tiny patch, the size of a postage stamp, that goes right under your heart. It powers itself using the energy from your own heartbeat and can fix your heart's rhythm if something goes wrong. No toxic cobalt, no lithium leaks, and best of all, no more replacement surgeries. It's made of polymers that your body just breaks down and clears away when the job is done. It literally just dissolves. This isn't a fantasy. They've already tested it in rats, where it powered a pacemaker for 90 days before completely disappearing. It could be ready for humans in just 5 to 10 years, because everyone wants to get rid of putting rigid metal inside the human body. This means a future where an implant does its job and then just melts away. Section 6. The green angle. Our current batteries are destroying the planet. Mining lithium tears up entire landscapes and uses insane amounts of water. Old batteries leak toxic junk into the environment. But these eel-inspired batteries are way cleaner. They're made of stuff you can find anywhere: salt water, special polymers, and carbon. Studies already show they have a 70% smaller carbon footprint than regular lithium-ion batteries. 70%! To be clear, this won't replace your phone battery tomorrow. But for things we only use once, like medical patches or sensors in the ocean, we could get rid of toxic metals today. Imagine a world where our gadgets just dissolve and go back to nature. Section 7. The DNA twist. Okay, get ready for a huge plot twist. Electric eels don't just shock things. They might actually edit them. Those massive electrical pulses can literally poke tiny holes in the cells of other fish swimming nearby. And in labs, scientists have seen DNA jumping between different species because of these electrical fields. Now, nobody's saying eels are trying to build superfish, but it means electricity could be swapping genes all over the Amazon. If nature uses electricity to trade DNA, what could we do with it? This could be a brand new way to deliver genetic therapies without invasive procedures. Section 8. Bottlenecks. Of course, there are some big hurdles. The biggest challenge is power density. Right now, these gel batteries are still 100 times weaker than the battery in your phone. Another problem is the gels dry out in the air, so we need to figure out how to package them. And also, how do you sterilize them for surgery without completely cooking them? To get a 100-watt defensive shock like an eel, you'd need a battery that's centimeters thick, way too big to put in a person. But the good news is, the best way to solve these challenges is to copy the eel even more, like giving the batteries tiny channels to carry salt water so they don't dry out. Section 9. The 5-year horizon. So what's coming in the next 5 years? The first thing you'll probably see is a tiny, postage stamp-sized patch for tracking equipment in hospitals, a disposable power source with zero metal. Next, we'll probably see injectable films that don't just power implants, but also hide them from the body's immune system. By the end of the decade, we could have exosuits for physical therapy with eel power woven directly into the fabric, recharging just from the person's own movements. It's a future where our technology becomes a seamless part of our biology. Conclusion: the big picture. Nature solved the problem of clean, flexible, high-voltage power a long time ago. The electric eels trick isn't magic. It's just stacking thousands of simple cells and firing them all at once. If we copy that design and replace the eel's biology with our gels, we get batteries that can bend, stretch, and eventually melt away inside our bodies. This is unbelievable. So the next time your phone dies, just remember, deep in the Amazon, a crazy fish is already living with the solution. Science just has to finish the download.